Okay, the last speaker is Jonathan Simm, and he will explain the International Levee Handbook.
12 minutes.
It did 6, right?
Micah, do you have the...
Oh, yeah, no, yeah. It's over here.
Thank you. Okay, so I always seem to end up presenting about a manual on the last session of the day, of the last talk, when everybody wants to go and get something to eat. So I will try to make it interesting. Bear with me. So I suppose I should say that this project is a very large collaboration involving many partners from Europe and from the United States, and so I have a lot of acknowledgements to a lot of people really in presenting this. I'm going to try to give you just one angle, in a sense, on the handbook, and that's to do with failure mechanisms. So I guess it links in with a lot of the discussion today in that sense. And so my presentation summary really is to start off by talking a little bit about the motivation and drivers for producing the International Levee Handbook, and how that, and talk a bit about understanding failure and how that's then influenced the structure of the handbook, and how the handbook has gone about thinking about failure mechanisms. I have to say I'm only very much skirting the surface of this whole topic. So the handbook motivation, I guess, is relatively obvious from a lot of the presentations that we've had at this conference already. You can list any number of severe events that have happened which have led to where levees have played a significant part in the flooding, either preventing the flooding or actually breaching and causing worse flooding. And there were a lot of technical issues around as well, particularly the sense that maybe the hydraulics and the geotechnics were not well integrated in the thinking and design process. So there was a desire to produce a best practice handbook, both for owners and operators, but also for designers and constructors. In a sense, we've framed our thinking around what you could loosely describe as the levee management life cycle. And if you think white, pink and blue here, I don't know whether those colours have come out terribly well, but in essence what we've got is a levee management cycle where there's some kind of policy has been set to define the indicators, and then you move into assuming that your levee has been built, but a lot of the levee stock that we have in Europe is already existing. And then you go around the routine asset management cycle of assessing performance, doing repairs and so on. But every so often you have a crisis, and that moves you into the inner loop where you have to do something much more rapidly. So in terms of what's going on in terms of failures, we've got sort of levee deterioration and damage, which is going on as part that you're taking account of as part of your routine asset management. You've got the damage and breach that goes on during severe events, and then you've also got the fact that you may actually have to allow for change, and so what may force failure in the future may change because of climate change or other factors that are going on. We've had a lot of discussion about fragility, so I won't dwell on this, other than to say in the UK we have this concept of different kinds of condition grades, and so that as your structure deteriorates, you will move from one condition grade to another, and as you get deterioration, your fragility curves tends to move to the left. Well, that's all very nice and neat and tidy, but the problem is that actually what we're talking about is mechanisms, and this slide is I owe to Remy, who's done a lot of thinking about, well, actually what we're talking about is mechanisms which happen at different speeds, and the issue is as much to do with how does the process relate to the loading event that's going on. So if a process goes on over many loading events, then we'd typically call it deterioration. If it's a process that happens quite rapidly within a loading event, which is what Remy is calling sudden there, then you're tending to think of it in terms of a damage. And this then leads us to the whole problem of the looseness of our language, because we talk a lot about failure, but actually when we talk about failure we have we mean many things. And so we've come up in the Levee Handbook with these distinctions that we have here. We're trying to talk about deterioration, damage and breach rather than failure, because failure is a very ambiguous kind of phrase. Of course, you've also got performance failures, and I'm not going to go into that in detail. It was indicated perhaps in that previous slide that I showed from memory, but we're focusing when we're worried about the structure of a levee really on these three processes: deterioration, damage and breach. And of course we don't live in a simple world where we've just got one mechanism, or even a situation where we can say it's either mechanism A, B or C. In reality we've got chains of mechanisms happening, and this is one example of a kind of a flow chart you might describe, but I won't call it an event tree or a fault tree, but a flow chart that shows how these various processes can link together. So I don't think we came to any massive conclusions beyond that, but we had to think of a structured way of thinking about damage in order just to be able to create the handbook, and so this is the framework that we've used. So moving on then, well, this is the structure of the handbook, so you have some kind of idea of what that's about. We have basically four main parts after the introduction. We have something which deals with the basics, the context and something about functions, form and failure, and then we've got basically sections which are designed for two main readership groups. One for levee managers, which deals with operations and maintenance, levee assessment and risk attribution and emergency preparedness, and the other group for levee managers, for designers and constructors who are actually designing things. And then we have a toolbox which enables us to define boundary conditions and then actually do the analysis of the levees themselves. So when we think about, I'm just going to run through some examples now of how that may be influenced in the way that we've discussed the question of failure in the handbook. One of them is to think about how that influences levee assessment. I've just given one example here to illustrate. In the UK we use an approach whereby we do a structured assessment of the flood risk, and having determined what the risk is in the floodplain, because we've done looked at multiple potential breach locations, we can identify how much of the risk in the floodplain is associated with individual levee segments, and this enables us to use that along with variations in crest level to assess which are the most critical parts. This histogram here shows the peaks in flood risk attributable to different levee segments. But that's a key, whether you do it by this method or whether you do it by an index-based method such as Remy was illustrating earlier on, it's really important to have some way of assessing levees and working out how much flood risk is associated with them. Because otherwise that then brings you on to thinking about the whole failure process, and you often need to know something about the failure process in order to do that risk attribution. Then in terms of the structure of the handbook, then we first of all provide a what I would describe as a non-numerical description of all these failure mechanisms, which is suitable for even the person who's not going to go into the analysis of it. So, and we have these three principal categories of internal erosion, external erosion, and mass instability, which are the principal categories of failure mechanism. And we also talk, of course, about overtopping as well. I'm not going to dwell on that. Although, again, that may well need to be managed, including in emergency events, such as are shown in the photographs. So, coming to deterioration, damage and breach. Deterioration is clearly something that's primarily managed through operations and maintenance of levees. You go through a process of assessing them, and then deciding what kinds of repairs you need to carry out, that's very obviously linked. A simple inspection may be insufficient, and you may actually need to then take that information into account in a formal levee assessment process. And of course, it may be that your operation and maintenance teams can't deal with those, that you may need to actually have a formal designed solution in order to be able to address those. Damage, the important point is that there are various damage mechanisms. Not all of them necessarily lead to breach, because you can often get to those damage mechanisms and repair them before breach actually happens. So mass instability would be a classic example of that. Here's an example I show from UK where we're getting shallow surface slips, but it doesn't mean that you've actually got breach of the embankment. So those different damage mechanisms that you consider in design, all the tools that you need for analysing those are given in the toolbox, chapter 8. And then chapters 9 and 10 describe how you deal with that in design and construction. And then finally, breach. We provide the tools for enabling you to assess breach dimensions and inundation hydrographs, because when you're managing levees, you still need to think about the possibility of that happening for flood management purposes. And then also, I think we had some presentations from the Corps of Engineers earlier today about how do you manage breaches and what kind of temporary repairs might you consider. And then, of course, finally, design. And for I think a big issue, which maybe we'll have an opportunity to discuss at our session tomorrow, is in Europe, is how do we actually implement the Euro codes for design purposes. And we had some presentations about that today, but the chapter 9 will go through the whole process of systematic process of selecting your levee alignment, your cross section, your materials, the construction sequence, and all the details of the internal design of the levee itself. So that's my time up, and I just summarise by saying that the failure mechanisms has been identified as an important practical cross-cutting theme right throughout the handbook, and we've distinguished between performance failure, deterioration, damage and breach, and how those link in with the hydraulic and geotechnical processes, and we're aiming to enable you to give you good guidance on that whole topic area. You may want to know a little bit about the next steps. Well, the target. Well, we're at the process at the moment where we've just gone through an international review process of the drafts. At the moment, we have about 1,000 pages of text generated so far. The technical work is intended to be complete in around about March of next year, with an aim to be published by the end of September next year, and possibly a launch. We're hoping to have a launch workshop early October for that. It will be available as a hard copy, and you'll be delighted to know as a PDF as well. And just a final plug is that there's a website if you want more information, and we have a special session on Thursday in room 3 from 2 to 3:30, and be very pleased to see many of you there, because we have some interesting questions to discuss. Thank you.
Thank you. Questions? No questions? I don't have questions either. I'm involved. So probably the 3rd and 4th and 5th of October we will have the the launching workshop or so for the Levee Handbook next year. Yeah. Okay.
So
well,
please do come to the other session though. There's some very interesting things to talk about.
Okay, all presenters, thank you very much for the good presentations. And this is the end of today. Yep.